Guys, hope you all are doing good. In today's session, we will be going through a few more trigonometry problems. I have taken all these problems from exercise number 11.4. There are around 4 to 5 questions which I gonna explain here. Let's read the first question. The question is evaluate 1 plus tan theta plus secant theta into 1 plus cot theta minus cosecant theta. So the question here is given as evaluate. So we just need to write any any one of the sine or cos or tan. So if you see, we have tan theta, secant theta, cot theta, cosecant theta. So tan theta I can write as sin theta and sin theta by cos theta, as well as cot theta, which is the inverse of tan theta, and secant theta is reciprocal of the cos theta. In the same way, cosecant theta is reciprocal of sin theta. So as we know all this, I'll just try to write all these terms in terms of sin and cos. Okay, now so what happens here? See, the given question is 1 plus tan theta, right? So in place of tan theta, I just have written sin theta by cos theta. Secant theta as 1 by cos theta. The same way, cot theta I have written it as cos theta by sin theta, and cosecant theta I have written it as 1 by sin theta. Okay, now here I just need to take the LCM. So here cos theta, and here if we don't have anything, we can say like there is will be 1 as a denominator. The same way here as well. So here I'm taking a LCM. So if I take LCM of 1 and cos, then it will be a cos theta obviously. So cos theta into 1 cos theta, and here already we have a denominator as cos theta. So even if we multiply with the numerators with the 1, then it will be the same value. So I have written sin theta plus 1. Okay, in the same way here as well, the LCM will be sin theta, and the sin theta into 1 here, sin theta plus cos theta minus 1. Okay, and then see here what I do, I'll just think about the formula of a plus b into a minus b equals to a square minus b square. See, if I think about it, I can say that I can substitute this formula into this equation, I would say. Okay, so I'm taking cos theta plus sin theta as a and 1 as b. So if I say that a plus b into this is a minus b, so I can write this as a minus b whole square. A minus b in the sense, yeah. So what I can write here, see, in place of a square I can write cos theta plus sin theta whole square, minus in place of b I am writing it as 1, so 1 square by as is. Yeah, sorry, here we have now I'm just again splitting into a plus b whole square, which is a square plus b square, and here 2ab, 2 sin theta cos theta, and 1 square is 1, so it will be and cos theta I'm writing cos theta sin theta as is same. Okay, and we know the formula that cos square theta plus sin square theta equals to 1. So in place of this value I'm writing it as 1, and it again already I have a minus 1 over here, just I have written the same, and we have 2 sin theta cos theta. So plus 1 minus 1 gets cancelled, and we will be having 2 sin theta cos theta by cos theta sin theta. So these two can get cancelled, as numerator and denominator are same. Sin and cos, I can say these two can get cancelled. Now we'll be having two value. Okay, so the question given is to evaluate, so we did evaluate it. right? We tried writing into sine and cos, and then we have after applying few formulas, then we got the value of 2 over here. Okay, hope this is clear. Now let's move on to the second question. Second question is, prove that cosecant theta minus cot theta whole square equals to 1 minus cos theta by 1 plus cos theta. See, question itself asking us to say prove that whatever the given LHS, we should try to write all this into cos, in terms of cos. Okay, cosecant theta is the reciprocal of sin theta. Cot theta also we can write cos by sin. So in both the terms I can have a sin in common, right? So I have just taken the LHS left hand side one, and I'll try to prove the right hand side value. Okay, now cosecant theta I have written as 1 by sin theta minus cos theta I can write it as cos theta by sin theta. So if I take the LCM over here, LCM will be the sin theta, and if I multiply first sin theta by sin theta will be 1, and 1 into 1 again 1, so it will be 1. As here also denominator is a sin theta, then I can write the same as is. So 1 minus cos theta by sin theta whole square. Okay, now here what I am trying to do, I am just trying to apply the squares separately to the numerator as well as the denominator. So what happens, it will be 1 minus cos theta whole square, and under this we have a sin square theta, right? So I'll try to write this sin square theta as 1 minus sin square theta. Okay, sorry, 1 minus cos square theta. Okay, 1 minus cos square theta here. Okay, before and after this, what I can do, I can write, if it is x square or a minus b whole square, I can write x into x, which means a minus b into a minus b. So here we have 1 minus cos theta whole square, right? So I am writing it as 1 minus cos theta into 1 minus cos theta. So 1 minus cos square theta. Again I am applying a square minus b square formula here, which I can write as 1 plus a plus b into a minus b. Here a is 1 and b is cos theta. So I can say that I can write this 1 minus cos square theta as 1 square minus cos square theta. So in that case what happens, 1 plus cos theta into 1 minus cos theta. And here I would say I can say that here 1 minus cos theta and 1 minus cos theta, these two are equal, so I can cancel those two, and the remaining part we have is 1 minus cos theta and 1 plus cos theta, which is the right hand side. So it is proved. Okay, hope this is also clear. And next, third question. Here again here we need to prove LHS equals to RHS. So here what they are saying, in the left hand side they have given 1 minus tan square a by cot square a minus 1 equals to tan square a. So our intention is to make sure that we need to get answer in terms of tan. So what I am trying to do this here is, I am writing tan theta is sin by cos and cot theta is cos by sin, because if in the end if I get the value in terms of sin and cos, then I can make it equals to tan square. That is the reason I am writing it as sin and cos. Okay, so in place of tan square I am just writing sin square a by cos square a. The same way, in place of cot square a I am writing cot square a, I am writing it as cos square a by sin square a, remaining 1 as is. Okay, if I go down, here if I take the LCM over here, LCM is cos square a into 1 cos square a minus sin square a. Okay, and denominator will be as usual cos square a. The same way, if I take the LCM over here, we will have LCM as sin square a, and it will be cos square a minus sin square a. So as we can see, these two are same. Okay, cos square a minus sin square a are same, so I can say these two can get cancelled. And I would say here As a result, it will be 1 by cos square a all divided by 1 by sin square a. Okay, if it comes to the top, then this numerator and denominator gets reversed. So it will be sin square, and as usual we have a cos square a in the denominator, so it will be sin square by cos square a. So I can write it as tan square a. Hope this is also clear. Okay, so I have proved it to in terms of a tan square a. And now let's move on to the fourth question. Okay, here. Yeah. If secant theta plus tan theta equals to p, then we need to find the value of secant theta minus tan theta. So what I can do here, before we directly taking this the quotient values and finding out the value of this, we can try to remember one formula, that is secant square theta minus tan square theta equals to 1. And we know our basic formula, which is already we are using for the earlier two problems, that is a square minus b square equals to a plus b into a minus b. So in this in this solution, what I do, I will consider a as secant theta plus tan theta and b as secant theta minus tan theta, right? So sorry, I'll take a as a secant theta, b as a tan theta. So what I can do, in terms of in place of a, I'll write secant theta. In place of b, I'll write tan theta. Okay, secant theta a plus b, secant theta plus tan theta into a minus b, secant theta minus tan theta equal to 1. Okay, which is already our formula. Okay, right hand side is the same value. And now in the question they have given secant theta plus tan theta as of p, so I'll just substitute the same value over here. Okay, in the next step I'll try to bring out this p into the right side, then it will be the, as here it is multiplication, as it is doing multiplication over in the left side, if it comes to the right side, then it will be divisible. Okay, so now it is 1 by p. Okay, hope this is also clear. Okay, now let's move to the last question. Okay, fifth question. The question here is, if cosecant theta plus cot theta equals to k, then we need to prove that cos theta equals to k square minus 1 by k square plus 1. Okay, so here our intention is, what we have to do before that, we need to write, see, thing is, we need to prove that cos theta equals to this. So our intention should be converting this cosecant theta plus cot theta equals to k in terms of cos, then I can find the value. Okay, now see, here we have a k square, which means there should be a square required for k. So for that reason, what I am doing, I am just applying a square on both sides as a first step, so that I can get the k square on the right side. Okay, now this is cosecant, which is I would say like a plus b whole square, right? The same way. Here again, this is a is a cosecant theta, b is cot theta. So a square, okay, a square cosecant square theta, b square cot square theta, 2ab, okay, 2 cosecant theta cot theta equals to k square, as says. Okay, cosecant square theta. Cosecant theta square theta, I can write it as against 1 by sin square theta, right? And cot square theta, I can write it as cos by sin. Here same way. Okay, here I just wanted to put one thing. The reason for I am writing into sines and cos is to get the value of cos theta. Our intention is to get the cos value, so we need to make sure. So now this equation is total in terms of sine and cos, so we should try to remove the sine also here. Okay, now see, let's take here, if you multiply both 1 by sin theta into 1 by, this will be cos theta by sin square theta, which is equals to sin square again, sorry, k square. Okay, now here 1 plus here if you take a LCM will be sin square. All these are same. LCM is sin square theta. And whatever the denominators are there, all those will be also the same. Okay, 1 plus cos square theta plus 2 cos theta equals to k square. Okay, and now here if you see 1 plus cos square theta plus 2 cos theta. If I say here a plus b whole square, if I'll try to apply a plus b whole square, okay, where a is equal to 1 and b equal to cos theta. Okay, b is equal to cos theta. Okay, so I can write it as 1 plus cos theta whole square. Right here I did written. Next, sin square theta. As we already know the formula, cos square theta plus sin square theta equals to 1. So if I bring sin square to the one of this side, then other side will be 1 minus cos square theta. So here I just have written the same. Okay, I just did the same. Here it is, I have written. Again, as we already applied the same value, same formula in the first or second question, then it will be again, I can write a plus b whole square, x square as x into x. Okay, and this is again 1 minus a square minus b square. So a plus b into a minus b, which is again 1 plus cos theta into 1 minus cos theta. So if you see, now, the remaining part will, these two gets cancelled, right? Okay, these two gets cancelled. 1 plus cos theta, 1 plus cos theta cancel. So we'll have rest value as 1 plus cos theta by 1 minus cos theta will have, and here we have k square. Okay, what I am doing here in this step, I'll just bring this 1 minus cos theta to the right. Okay, if I bring it, it will be k square into 1 k square into cos theta, k square cos theta. Okay, here here what we can do, here if you take a cos theta as a common, if I bring cos theta into one side and other values into other side, so if I bring this cos theta into the left, then it will be k plus k square theta. Okay, again here k square is as is. Now I am bringing this one to the right side, so it will be k square minus 1. Okay, now let's take a common from this equation. So it will be, if I take cos theta common here, it will be 1. Here will be having k square. So if I put cos theta onto the left, and if I bring this whole 1 plus k square to the right, then it will be k square minus 1 by k square plus 1, which is our HS, which is our required value. Thanks for watching the video. Thank you.